And we're on! Welcome everyone to this second lecture in JavaFX. The topic for today is more controls and a bit more controls and some animation. And first off, as you can probably see, we have about 78 slides to go through. So some of you are thinking, don't you like us? Well, don't worry. Most of these slides will be glorious, colorful images of important stuff like Star Wars and Pink Floyd. And the rest will be code, loads of code. I try to cut and paste as much code as I possibly can so that you can use it in your programs and try to understand how it works. So, jumping right into the agenda, we'll see that we will begin with basically loads of controls, and we will not be able to look at each and every control that's available in JavaFX because they are too numerous. There are so many of them. But we'll look at a few things that are vital and important for you to understand how controls work and different controls work in JavaFX. And we'll also look a bit into the stuff that perhaps makes this a more modern framework for creating GUIs, namely multimedia and images and stuff like that. From time to time, I'll make reference to the old ways of doing this, the swing ways of creating graphical user interfaces. If you have no idea what swing is, then good for you. If you do know, then you'll notice that everything is so much better when we talk about JavaFX. In the middle somewhere, we will talk a bit more about events and events handling. We will cheat a bit about it in the slides before, but we will have a part where we will discuss listeners and event handlers and events and so on. This is a fair bit more easy, I'd say, in JavaFX. Events and events handling is all about trying to react upon whatever's happening in the user interface. And event handling and listeners is the way of doing it in Java. The last part in that segment, which has absolutely nothing to do with mouse and keyboards, is styling, but that's just a few slides where we will talk about how it is possible to style. I will not go into detail in that part because it's too broad. Lastly, animations. Someone at Oracle thought, let's go crazy with animations. So there's loads of support for animation and different types of animations in JavaFX, and we'll look more deeply into that. But the meat, or at least the first part of this lecture, will be about the different controls and how to actually work with JavaFX. When you get the idea of how it works, you can apply this onto all the different controls that are available. So just a selection of controls, but perhaps the most used controls. And when you know how these work, you will be able to use all the other different controls available as well. And we will end, as I said, with animations, which is part of JavaFX, but as you'll see later on, it actually inherits more from pure Java than it does from the JavaFX packages. So, but because buttons and toggles and menus and stuff like that is fairly boring, we will begin with images. So, images are often used in applications. Any kind of application today will use an image of some sort. And JavaFX supports a large number of common file formats. We have JPEGs, PNGs, GIFs, and BMPs. And for all these images, yes?
What about the vector files?
We've got a question about vector files, and currently we have no real support for vector images as such, for example, scalable vector graphics. So they cannot be displayed right off. There's some work concerning it, but we do not have, for example, SVG support right now. For all these images, these bitmap images, we work in the same way. We have an image view, which is the control that actually shows the image on the screen, and we have an image object which holds the image itself. And we have this separation because the image object is merely the image itself, the PNG picture, or whatever it might be. Whereas the image view is displaying whatever part of the image we want in whatever way we want to do it. In most cases, I would suspect that we just want the image right there. But in some cases, we might like to change that. And that is then the work or the responsibility of the image view. Images are loaded. This is always kind of a trouble. By default, they are loaded from the class path of the project, which is the bin directory. But we'll show a few slides later on how it's possible to use them as a resource instead. But you'll see many ways of doing this along the way. All right, first image of me on a Friday night. This is a small program that merely displays an image, and we've been able to fit the entire source code for this. And if we look into the application itself, it's called test, and in the start method we begin by creating an image object, the image, which points to the image file itself. And then we have an image view, and then we connect the image, or rather we set the image that we want to have to the image view by the setImage method. And then we just add everything up into a group node and then display it on the scene. And then we get this beautiful image. As I said, it's quite possible to use other means of doing this image finding, so to say. And perhaps one of the easiest, when you get to know it, is to use images as resources. It's easier because if you have, for example, a Eclipse project, you merely drag and drop the images to the project folder, and with this single line that you can see in the middle of this page slide, you just reference the image. And you don't really need to know exactly what that means. Basically, it is reflection which calls out for the currently running class, or the object of this class, and it fetches this resource as a stream from within that one. I usually use this way of doing it, and don't really care much for what exactly that is. Another reason for using this way is actually because loads and loads of examples on the internet show it in this particular way. So it's important to know the different ways of doing it. Other than that, there's no difference. As soon as you've loaded the image and the image is in the image object, then you use it as before. But as I said, it is possible to actually work a bit on the image, or rather on the image view. So using the image view, we can set the width and the height to specific sizes. We can adjust just one of these axes, and then we can set preserve ratio true, and then we will have the ratio preserved, and so on. In the example, we'll also see that we take out a rectangle, a two-dimensional rectangle of the image, and rotate it slightly. And that's another thing that you can do. There's loads of more stuff that you can actually do on this, but as I said previously, most of the time we probably just looking at the image and showing it. This is my house. The original image was 400 by 400 pixels, and in the program that you see running to the right, you can see the viewport of this one. We have cut out a rectangle and we have rotated it slightly in code when we run the program. And the code for that is here, where we again begin by loading the image, the entire 400 by 400 pixel image, and then we have an image view that we set to this image by sending it in the constructor. We set a width to 300, so it's smaller than the original size of the image. We set the preserve ratio to true, so that whatever we do later, we will have the ratio preserved as it was to begin with. And then rectangle 2D is the class that we use in order to create an object which is a rectangle which we will put onto the viewport and cut out that part. So the coordinates are for the rectangle, and then we cut out that by setting set viewport to this rectangle, and the next line, set rotate 45, rotates the image slightly. The rest of the code is stuff that we've seen before. We create a group, which is merely the root layout, so to say, and we add the view, and we add this create this scene, and we add that to the primary stage. So this is a bit more of what you're able to do with the image view. And as I said previously, there's loads and loads of stuff more that you're able to do by looking at the image view API. Before going into the boring stuff with buttons and stuff like that, we'll have a few more cool stuff, cool things to do. First off, multimedia. The Swing library or framework that we used before in Java had very limited ability to actually play multimedia like movies or audio in any real way. But in JavaFX, with of course the hardware acceleration and using in the back end either OpenGL or DirectX, depending on the platform, we now have support for much more than we did before. So for example, it's possible to play MP3s out of the box. As you'll see later on here, you create quite easily a program that plays an MP3 file. But there's also support for many other formats like WAV and what have you not. And for video, to begin with, they only had FLV with a rather proprietary VP6 video and audio, but they've extended this, so now we have MPEG-4 videos that we are able to play right out of the box as well. So we have quite a lot of support for the most common ways of displaying video or playing audio. But not just that. We cannot just play it. We can do that if we like, but we also have some better control over it, like seeking, progressively downloading. We have volume control and all that stuff as well, of course. And the code for playing in MP3. Yes, question.
What's the current status on the WebM container in JavaFX?
We got a question about the current status about WebM, and I actually don't know right off the hook. So we'll have to look that up or ask our really nice friend Mr. Google. I don't really know right now. To play an MP3 file, which is one of the most common ways of playing music today, we have this media object. And this media object works almost identically to the image object. So we create an object of this class, and we read the MP3 file in this case, and that's just the music, so to say, just as the image object is just the image. And here we have the media player, which is kind of the equivalent of the image view, which takes care of the music and the playing of the music itself. So we attach that to, or rather we attach the music to the media player. We set up some nice layouting and stuff. And at the bottom you will see that we have a button, a play pause button. And this one has an action, and we'll go more into the events later on. But it checks the status of the music player, which is our media player in this case. And depending on whether it is paused or if it isn't, we just call musicplayer.play to play the music, or musicplayer.pause to pause the music. We have better fine-tuned control as well. We are going to, unfortunately not here, but we're going to see the program at least. And this particular song has one of the best guitar solos ever. So therefore I have a special button which you can press in order to get to the solo stuff. And we use a SetOnAction for that one. And we see we have musicplayer.seek and then a duration, which puts us forward in the music file to a specific position. It will look something like this. It's I took an MP3 of the live performance of Comfortably Numb from 81, something like that, by Pink Floyd, of course. And you can press the play and pause button, and while it's playing you're still able to press to the solo, and it will jump directly to the really great solo, which you all should listen to, of course. Nice there. Very easy to get this music up and running. And while you might think this is fairly basic stuff to get this up and running, well, in previous years, for example in Swing, we had no support at all for this. We had to rely on third-party libraries that didn't thread really nice for us. So this is a great improvement. We also have a video example, and again I will not show you the example more than a static image. And it works more or less the same. We have a media object, and notice that no matter what kind of media we're using, whether it's a movie or an audio, the object holding this media is of class media. And then we have the media player again. We attach the movie, the media, to that media player, and then we can do all the stuff that we did before in this one the same way. The important thing here is that we set the autoplay to true, and we put all of this as the only thing that we have in this program. So no buttons, nothing like that. But just as we saw in the previous example, it's possible to add buttons to add this kind of functionality. Pause, play. You can load a new video, whatever you like to do. It looks something like this, but it's supposed to be moving. It did when I created it. The trailer for the Star Wars movie, The Force Awakens. I have seen it. Have you? Yes, is the correct answer. Now on to something perhaps a bit more boring, but in most cases we need this as well. So we cannot just have loads of audio and video and images popping around. We need to have simple things like labels as well. And the label class is what we're going to use for that. And we saw an example of this in the previous lecture as well. And while it's quite possible just to display text in it, the label in JavaFX is more versatile than that. It's possible to add text, images, or both text and images at the same time. And as this is a node, we can apply different effects like drop, shadow, reflection, and all of that as well. Text is most often of a specific typeface or font, as we commonly call it, so we can set the font for it as well. Any font that's available on your system is possible to use, or you could possibly add a different typeface if you like with the program. This is the code, and we create a label, the label I call it. Yeah, nice name, I know. To the constructor I just send a small string called with the text that start with encyclopedia. I set the font to something that I have on my computer, the URW Classico T, and we set the size to 42. We also have a label, and then we take this an image, and then we take the label and we add an image view of this image to this label with a gap of 10 pixels in between. That means that this label, called the label, will now contain both text and an image. We create some nice drop shadow. We create a new label called the intro and set the text to the opening scroll of episode 4. We set the text wrap to true, meaning that we define a size, the preferred size on the line below, to 200 by 200. And if we, as we've done here, set the wrapping to true, it will wrap the text inside of this box. Otherwise, it will just go on forever. And lastly, a little rotation on this one as well. And then we put everything in a V box, which serves as a layout for this one. And we get something like this. Yeah, I know. Perhaps not the most useful thing to do, but it's there. And we see that we actually have the Classico typeface for the Star Wars Encyclopedia. We have an image, and both of these have a drop shadow. And also notice that they actually get their drop shadow not together, but for each one of them. So the text has its drop shadow and the image has its drop shadow. And after that we have the opening scroll slightly rotated. Yeah. Buttons. Buttons, as well as labels, they inherit from the labeled class, so much of the stuff is actually the same. So adding an image, you can do that as well if you like. Text and image and positioning, everything works exactly the same for these two controls. The only difference is that we most often connect some sort of event listener to a button in order for it to actually do something than when we press it. In this example we'll also chain effects, and you'll see that in the image here that we have an OK button which has both a reflection and a drop shadow. And that is really a stupid idea, but it's merely to show you what's possible to chain different effects together. And for anyone who's actually good at this, you can get really nice effects by doing that. Also, in this example, I will show a mouse event, but I'll just show it here and we'll get back to it later on, where we'll try to explain more in depth how this actually works. So the code, part 1, we create some sort of layout, in this case an H box. We create a drop shadow with some offset in the color blue, and then we create a reflection with a fraction of 1.8. Now we have two different effect objects, and we chain those two together by stating ds, which is our drop shadow, dot set input, meaning that for input for that effect will be the other effect. And that's how you're able to chain these together. We create two images, check and delete, which we saw previously down there, a cross and a tick. And we create a button, and this button has set max width, set to double max value, which is a shortcut for actually creating them exactly the same size. And we do that for both of them. For the exit button, we set this image with a new image view for this exit image. And we set the content display to top, meaning that we want our little icon on top of it. And then we add that one to wear them all to the layout. Here are a few lines where we are actually using the mouse event for entering and exiting. But as we'll see in a few slides, this can be done quite a lot easier, and we'll get back to that. But the important thing here is that for the first one, the mouse entered, we set the effect to ds when we hover it, when we put the mouse on top of it. And we set the effect to null, meaning no effect, when we exit the area of the button itself. Setting effects for the buttons like that, this might not be a good idea, but sometimes when we enter a mouse button, perhaps we would like some short information down at the bottom of the window, something like that, and then that possibility might actually be a good one. But now let's go on with a bit more higher up controls. A few ones that we will probably use in our applications from time to time. You will of course use the labels and the button as well quite a lot, but there's so much more fun we can do. And first off are the radio and checkboxes. So radio buttons and checkbox, they are these little markers that you can have, that you can either, for the radio button, you can have one active choice, or you can have several ones with the checkbox. And in order for these to be in a group, if for example we have the radio buttons there where only one of the buttons can actually be active at once, we put these into a toggle group. So it's possible for us to toggle between a set of radio buttons. And then we read the isSelected method to see if a specific radio button or checkbox has actually been activated. It's possible to add a listener to these as well, but most often that is more or less bad behavior, so don't do that. So the code, and you'll see the example in just a few slides. There's quite some setting up. We create a label with a new font. in size 42. We create a VBox called Box Crust. This is a pizza maker. And first up, we need to make a choice between either deep pan or thin and crispy crust for our pizza, so the bread. And in order to do that, we create two radio buttons, deep and thin, and these we put into a toggle group, and then we add these to the box itself. And then we do exactly the same for the topping. We have a number of toppings which are checkboxes, because you can mix and match these however you like. Have all four of them selected, just one, or just two, or whatever. And then we add these to the box topping as well. And when that's done, we have also a button, and for this button we create an SetOnAction which checks first is deep selected, then we have a deep pan pizza. Is thin selected, well, then we have a thin and crusty pizza, and then we go through all the different alternatives. Is olive selected? Is anchovies selected? Is pineapple? Is mushroom? And so on. And we add all this up to a string, and then we print out the order in a label called the answer at the bottom. And it will look something like this, or exactly like this actually. The Pizza Maker Mega Ultra Plus, because you need to have all of those little words in it. On top we see that you decide your crust, deep pan or thin and crispy. And then you select your toppings. The first one, radio buttons, because you can only take either or, one of them. But toppings, you could select olives and anchovies, but that's wrong, because only pineapples and mushrooms are any good. But possibly you could put something for olives as well. Yes?
Is there a way for getting the checked radio button in the toggle group? For example, a method for getting the checked radio button in the toggle group?
Well, you mean to read the radio button or to set the radio button?
No, just that I want to get, for example, I want to get the string of the radio button that is checked in the toggle group.
Yes, you mean that's text string, yeah. So the question basically was that is it possible to get the string that is the radio button? Well, if we go back to the code, we have deep and we have thin, which are our objects, radio button objects. And yes, it is possible. I don't know exactly which method, but it is possible to look inside of this and see exactly what the string is as well. And you can change that if you like as well. Okay, nice. Anyone for pizza? Next off, combo boxes, or as we call them in other situations, drop-down boxes. We have a little one-line box, so to say, with a possibility to drop down a menu of different alternatives. So a selection is made from a list of elements, and these are shown by ticking or clicking the button itself. These were introduced quite late on in JavaFX life, so there's quite a lot of reference still to choice box, which is a simpler form of a combo box. That was the way to do it before these two latest versions of JavaFX. And in this one, you get the value from the selected item with get value, and then you can do something with that. We'll see an example of where we'll load an image depending on which one of the different selections you've made. Also, good thing about combo boxes is that they will display a short scroll. They will display a scroll bar if the list is too long. So you will not be faced with this long of a selection. This one, we have combo box. I call it Pink Floyd, and it is of type string. And I enter all the different studio albums by Pink Floyd into that one. And I do that by using the getItems.addAll, and then just as strings add the different albums in the order that I want them. The rest of the stuff in this code is to set up the layout itself. It uses a VBox, and we put in a image, and we have a default image, and we'll later on change that with a bit of a reflection and so on. But the logic in this code is down here when we have SetOnAction. So whenever we select something from the drop-down list, tick, we will have this SetOnAction fired, and then we go through the different values. So pinkfloyd.getValue, if it is the pipe at the gates of dawn, we will display the appropriate image, and we do that in our show album image view. So we replace whatever image we had previously with the current one in using the show album, which is an image view. And when we run this program, it will look something like this. First off, the default, which is a Pink Floyd logo, which happens to be tattooed over here as well. And then you have the drop-down menu or the combo box, where you just select, and you will see the list of different albums, and you select one. And when you do that, the on action is fired, and you will see an image of that album. First, Wish You Were Here, and down there we see the Endless River, which is the latest and presumably the last Pink Floyd studio album. And it's great too. Fairly easy to work with, and that's the idea with these controls. They shouldn't be too complicated to use really, because you want them in your programs. However, if you have too many things to choose from, a combo box could be cumbersome, and then a list view, a box with a scroll bar, is a lot better. It also gives you more control for multiple selection and stuff like that as well. And there are a number of different methods for this one, so not just the SetOnAction, but also get the selected index or item or focus index or focused item. So the item or the string, for example, that we have selected or focused. And in this example, we will be using an observable list, which is one of the additional data structures that we have in JavaFX. And that works basically as a array list or something like that. However, the observable part of it means that it can connect to other JavaFX controls, and it will automatically listen to changes. You might perhaps remember from last lecture that we had an example where I typed something in the lower box, and that was at once displayed in the top one using binding. And an observable list is possible to bind in that way. The list view itself, which is the visible part, is merely a class, list view, of a specific type, in this case string. And then we have this observable list, which I just populate as a array list, so a number of members of the Jedi Council. Well, these are my lecture notes, so I can do whatever I like. And then, after that, we set this observable list to be with the Jedi list, which is the list view itself. And then, again, a number of different images are going to be shown. So I create, in this case, an array list of different Jedis in the council. And what I do at the near bottom, where I have the Jedi list get selection model, I decide that I want to have a selection index property that I listen to. And we'll talk more about these event listeners just a few slides. And whenever I do that, whenever this happens, that I select something, I want it to display that index number from the array image into the image view. And when we run this, we will have something like this. So first off, nice image of a few of those in there. And then we have selected C13, which is still one of my favorites. But he died, so too bad. And we can just select whichever one we want, and it shows up in the image. There's a bunch of more things that you can do with an image, with a list view, which I'm not going to tell you right now. But you can, for example, make them editable. So you can decide that instead of filling it up to begin with, you can make each and every item in this list editable by just double-clicking it, and then you have a text area there where you can add something. So they are quite versatile, but I'll just show you the basic usage of it. Yes, well, let's take these charts as well before we take the break. Addition to JavaFX, which came as a surprise, are these charts. They are built-in classes to create charts in JavaFX. Presumably, that's because they want to create business applications, or they want you to create business applications with JavaFX. Business applications are going to be used by people having fancy titles like CEO and I don't know. You know, these nice people running around with bags. And they understand only charts. So therefore, we have the possibility to create pie charts, line charts, area charts, bubble charts, and also scatter charts, which I have no idea what they are, and bar charts. Those are nice. And all of this is included. Yes, sir?
Is that also available with like candlestick charts and so on, finance and so on?
There was a question about a specific type of chart. Well, these are the built-in ones. There's of course a chart superclass which you can derive from and make your own if you like. Yeah, you never know. you may need it. Okay, this is what we're going to do. Every year when I have this lecture, I check the TIOBE programming index for how popular a specific programming language is. For 2014 and 2015, the leading language was C, which is a fairly dull language, but quite good. However, 2016, Java is on top spot again. Yay for us! And by a large margin as well, as you can see. And this is how it works. You define the sizes of these. And as you can see, Objective-C is right down in the bottom in 2016. And that's a good yay for us as well. And then we have C++ and C#. They're there if you want them. Okay. Sorry. Doing this then, well, there are a number of classes, and when creating charts, they basically work the same. So in this case, we want an x-axis and a y-axis, and we make these of category axis and number axis because we want to have a category of programming languages, and we want to have a number axis where we define different ranges or values rather in this case. And in this case, it will be a bar chart. So therefore, we create a bar chart of string and number so that we can have these two different types. We call it programming languages January, and we set the labels, and then we create series of values. One series for every year in this case. So values for 16 is an XY chart series, and we add the language and the percentage. And we do that for all the different languages. And we do that a similar series for 2015 and again for 2014, but I'm not showing all of that. But that's it. When we're done with that, we've actually created our bar chart. There's, of course, a bunch of more stuff you can do, like deciding the colors and where to put the legend and stuff like that. But if you just want something that looks like this, and it scales nicely as well, then these few lines of code is all that you actually need. All right, dialog boxes and alerts is really cool after the break. So 10 minutes break, everyone, 10 minutes. Go and buy a pizza. Nice. Coffee, cinnamon buns, and yeah. Taking it cool. Thanks for that. All right. Charts. They were really a surprise when we got JavaFX. Quite nice addition. Most of us thought, well, sometimes you can do stuff with a chart which is quite handy. However, a noticeable omission was the dialog boxes and alert boxes and stuff like that. Things that we've used in many different programming languages just to fire up something, a small dialog box saying the value of X or whatever it might be. These were not present. Not in the first JavaFX 2, not in the 0.1 update, not in the 0.2 update, not even in JavaFX 8 when it arrived, not until update 40 of JavaFX version 8, so to say, they added dialog boxes. I have no real idea why they waited that long for doing it. It's been available in the FX controls library for a while, but now we have them. They're here, and I think that they're fairly nice and fairly easy to work with. They come in many shapes and forms. They're pretty flexible. As you'll see later on, it's possible to create your own dialog boxes. They also, and that might be a reason why it's taking so long, they rely fairly a lot on Java 8 and on Lambda expressions and stuff like that. So in order to have a smooth adoption, it might have been the case that they waited for this. So we will, for example, see that many of these examples later on, at least when we get something back from the dialog box, will use a data type called optional. And optional is a new data type introduced in Java 8, which tries to serve as a safe reference to T, whatever that might be, and check whether this has a value or if it is null, for example. And it does that with a method called isPresent, and it says if it has a value or not. But we'll see this when we get to the examples. So it's a bit different than from what we've seen before. However, a short, simple first example of an alert where we create an interface which you don't see here, which is just the window, and then we have a button there which says press me. But to this on action for this one, we have a method where we create an alert, as you can see here, and we have an alert of a specific type, namely information, and that gives the nice eye in a round blue circle. And we set the title, which is on top, important information, the header, which is your actions will have consequences, and lastly the content text, which tells us, or rather you tell the user what to expect when pressing OK. You will now destroy the earth. A alert or a dialog is fired up with show and wait, possibly just show, but with show and wait it will block the underlying interface from doing anything else. And sometimes that's a good idea, sometimes it's not. But depending on your application, it's possible to do that at least. Alert is one of the dialog box classes that we use, and we can use them in many different ways. We can change the alert type, like here, warning and error. In warning and everything else is the same. I hope you know what you're doing. The next step could possibly destroy the earth. And error, well, now you did it. And these images, they are built in, so you will get these. But it is possible to change them as well if you like. Nice addition to what we had before. However, one nice feature of these dialog boxes, and something that I've seen people use extensively in Swing and when learning the Java language and also other programming languages, is to actually fire up a dialog box and ask for input via this dialog box. And that's all then possible, and the return we get is of this type optional. And there are some predefined things like type button OK, and we'll see text in just a while, so not to worry. But we can also have different buttons like OK, cancel, and we can define our own buttons, so we can have an array of buttons with different types that we define. And as I say here, there are at least 3 different ways, depending on how much Java 8 and how much Lambda you'd like to use when you get the reply back from the dialog box. And we'll use something in the middle, which uses a little Lambda and a little Java 8. So this one is still an alert, but it is of type confirmation. Please confirm. And as you can see, we halfway down approximately we have the option of button type, which takes the result from the alert show and wait. So it fires up the alert and it waits for the return, and it checks if the result that .get is of button type OK, then it will show you press the OK button. Otherwise, you press cancel or escape. We could also check for it having no value at all, not being present if we like. But in this case, we have these two, and it says here in Swedish OK or avbryt. And it, of course, picks up whatever language you're using. So if you're German, you will have something like an essay for OK and 3 essays for Abbruch or whatever. Yeah. Alles gut. Let's move on before this gets dangerous. We'll move on with the mouse and keyboard. Actually, we will return to the dialog box in this section because I will show you an example of how to create a custom dialog where we decide actually what we want to have in our dialog box. But before we do that, we have been cheating on the events that we are using in JavaFX. We've seen this SetOnAction several times. But let's dive in and see what we actually mean with all of this. And in Java, whether it is JavaFX or it's Swing or it's AWT, we have these events and listeners for events as the foundation of how this actually works. We have seen the click event for the button, which we actually use the SetOnAction. The button itself is seen as an event source. Anything that for anything to happen, we need to have an action event to fire, and this action event needs to be listened to by an event handler. And all of this has been fairly obvious to the programmer when we did the old ways of programming with Swing and so on, because then we created something like you see here, the old pre-lambda ways of doing it, where we had a SetOnAction. It wasn't called that in Swing, but we can still use it in JavaFX. So SetOnAction, okay, we have an action. For what are we going to listen? We need a new event handler for something. So we create an anonymous object of type event handler. What is it supposed to be listened to? Well, action event is what it's supposed to listen to. When we create this anonymous object, it needs to implement a specific method, in this case called handle. And label set text is something that, well, whatever's happening in this method. What Lambda in Java 8 has done is that we know that for SetOnAction, what we are going to implement is the click, so to say. So why all of this extra code? We don't need that really. We know that we want to listen to an event, so therefore we just replace all of that with an E, and we have this little arrow notation, and we don't have to write all of this handle action event E because, well, it's the only method that we need to implement. So therefore Lambda, and we're not going to go into exactly what happens, but Lambda has made it possible for us to just disregard all of this and just, so to say, focus on what we're supposed to be doing. So instead of hooking all of this up, we just have 1 or 2 lines of code. But what's actually happening is still this. So what I just said was that we have a handler. We must register an event, an event source, the button. It must be of an appropriate type, an interface. And the event handler is called a listener in Java, and the button is set to listen to a specific event that fires. And we can also have different events that we listen to, and each button can have different events, but we can also push these events to different controls if we like. And and this is also how we are going to use keyboards and mouse and stuff like that. And here's just a small shot on what the different events that we can fire for different source objects, and the event registration method where we bind our listener. Most of this we are not anymore going to really delve into, as Lambda has shortened it. But from time to time you will see this as well. And remember that any example of JavaFX in JavaFX 2.1, 2.2 uses the old mechanism, because this lambda expression has only been available since Java 8. Here's an example. Now, nice images. You see 5 planets, and you can take the mouse and you can hover them, and you can click them. And if you hover them, for example, now we are over the planet Alderaan. Well, what did you expect? Huh? Yeah. So the text in the middle changes to this planet is called Alderaan. And if we click, it will put up a custom dialog box with some information about this beautiful planet. And then we have a button there. Got it. And there will be a test. No, there won't. Setting up this window is something like this. We create a text which will be displayed in the middle, the planet, a text at a specific coordinate. And then we have a lot of images. And we have the image views, and we just, with this set layout X, set layout Y, we position the planets onto the beautiful backdrop. So what this does is just put everything onto the screen. I will not show you all the different planets, just Alderaan in this case. But what we are doing is that we create a custom dialog called Dialog, with a name about the planet. It has a button type, which is of type OK done, as you can see, with the name got it. And we add that to the dialog pane. And then we have a label with a specific size. And that's the reason why I created my own dialog box, because I wanted this size of text that I could fill in. So the other dialog boxes or the alerts would just show me parts of the text, but I wanted more text. And then we have 3 lines, three listeners for all the images. So for each and every image we do this. So for Alderaan view, which is the image view for the planet Alderaan, we use the SetOnMouse entered. So when we put the mouse pointer above the image, which is Alderaan, it will set the text to this planet is called Alderaan. And as you can see in this example, we use the lambda expression because we do not want to type too much. So instead of all of the lengthy things that we saw in the previous slide, we just have the E for the event and the arrow symbol, and then the method that we want to implement, and that is the handle method, but we don't need to call it that. It works exactly the same for mouse on mouse exited. So if we want to exit, so when we take the mouse pointer away again from the planet, then the text will reset to whatever it was in the beginning. And lastly, SetOnMouse clicked. So when we click a specific planet or image, in this case, we will set the dialog header text and set the info text, and then set the content to this info text and show and wait. So just wait for the user to press OK. And then all of this needs to be done for all 3 of the different, all 5 of the planets. So basically what happened here was that we have an image and we attach listeners to the actions. For example, hover or enter this image. It's an image, so we just enter the image, or we exit an image, or we click an image. And that is done with these in my case, I'd say it's rather few lines of code. The keyboard works something similar, but we have a key event, and the key event has a method called getCode, which is the code of whatever key was pressed. So, for example, key code home is the home key over there. The key code tab is over there. Key code up is over there. This one is what? No, I'm kidding. Key code O. But you see, you can actually get to all the different keys on the keyboard. And you can also use key code combination to read a combination of keys, where you have the main key first, for example, control, and then you listen for R as well, so control R. And you can attach as many secondary keys as you like, so control shift Star Wars could mean something in your application. Responding to key press, again, we have the old ways and we have the new ways. I like the new ways because there's so much less to actually write. Also, if you use something like NetBeans, but we're using Eclipse here, I know, but if you use NetBeans, it will automatically say, well, you use the old ways of doing stuff, would you like to make it the new ways instead? Yes, and then and just this left. So everyone wants you to use the new way. The old way, again, set on key press is what we are listening for, the action, or rather the action that we want to take. So set on key press, when we press a key. In the old ways, we created an anonymous object of event handler type for a key event and implement the handle method and then check whatever we want to do on key up, for example. And the lower one is for the Java 8 way, where we have again set on key pressed and then E arrow symbol method. Much less to write. Thumbs up. More images, less code. Something to notice in this example here is that I choose to attach the reading or the listening of key presses to the scene itself. You can, if you like, add this to any one control. So if you focus on the image view, for example, you can press different keys if you like, for example. But then it will not work if you're somewhere else. If you want the key press to be universally detected, then you attach it to the scene, because the scene is on the top of the hierarchy. So then it reads all the time, whatever you have perhaps focused on the screen. Okay, in this case, we create first an image called tie, and we put that one in an image view, and we put it using set layout X and set layout Y at a specific place on the screen. And then we have another one which is just the background, and we add these two up. And then lastly, which is the important part in this example, we have scene set on key pressed E. And then we check what key was pressed, and I check for key press up, down, left and right. And if, for example, I press up, then I change the position of the image up, then the Y will be 10 pixels less. And then we get something like this. And it moves. These are just two images I'm jumping between, so. But in real life, if you write down this, you can actually run around with the TIE fighter in the trench. It looks really cool. Yeah, again, my slides, my examples. But a nice way to just read the keys from the keyboard. Lastly, and this is way out of place, I don't know why it's still here, it should have been before. We've seen how to react to the mouse and to the keyboard, and we saw that was fairly simple. Here's styling with CSS, which is, as I said, way out of place, but just bear with me. If any one of you have tried out client-side web programming, you've probably seen something called CSS, cascading style sheets, which consists of rules of selectors with values. So there's a rule called H1 for heading 1, and we can color that blue by writing something like this. Okay, this is so familiar to programmers, because the web is all around us, and most of us will eventually end up on the web. And then we'll go back to JavaFX. But when you're on the web, you will notice CSS and CSS styles, and you can download them and so on. And in order to make it easy to skin JavaFX, Oracle decided to use a CSS-like format for doing this. And there are a great many different rules that you can apply onto a scene, and that's exactly what people have begun to do. There's a reference guide, and I'll show you an example of JMetroDoc CSS file. You just download this CSS file, and it takes care of skinning buttons, drop-down lists, everything that's available in the interface, so that it matches a specific platform. So this JMetroDoc is supposed to make the look and feel of your application conform to Windows 8 or 10 or something like that, in the style of buttons and radio buttons and stuff like that. Also, there are Aqua, so Mac OS-like CSS files that you can use in order to make your application look like a Mac application. And just to show you what it looks like, I have a small example here where we use styles twice. We see that first we set out a VBox with some spacing and so on, and then for this layout we use set style, and then we just put in a specific style, in this case -fx-background-color :black, meaning that we want our background of this application to be black. So that's one way of putting the background being black. And this -fx-something, all of these are listed in the reference, so it's possible to get what ones you are going to use in order to style a button, for example, or a text field, or a text, or whatever you like to do. In this case, we just put up a button, and we have a combo box, and we have some checkboxes. And right down at the bottom, you see that we have a scene, getStyleSheet.add, and then we just name the CSS file that we'd like to use. And when we do that with this specific scene, it will look something like this. And this is, they tell me, something that looks similar to Windows. I have no idea because I haven't used it for years, but they say it doesn't look any good, so it must, no, sorry. It's quite nice, and it was fairly easily done. just search for JavaFX themes and you will find a number of these. Some of them for specific platforms, some of them, well, just very nice. And the good thing is that it is fairly easy to create them. Now, lastly, we will talk about animation and how that works in JavaFX. Animation has seen quite a lot of attention in JavaFX. If we compare it to how it's done in Swing, we could say that it isn't done in Swing. But here we have a large framework around animation. And part of this is, of course, that JavaFX adds hardware acceleration. But we also see it in that JavaFX adds a number of animation classes for different purposes. So they're there and you can use them for different purposes. All the way from down to reading the pulses to creating animations that you just play, so to say. And we will see all of this. We have on the top animation and animation timer and well, I think I did this and this is very good, so have a look. The idea here is to show the animation hierarchy where, and this is important, animation and animation timer, they inherit directly from objects, so they are not really part of the JavaFX package as such, but inherit directly from objects. So they are very well integrated into Java. The animation is divided into timeline and transition, where timeline is keyframe based animation, where you decide what keys which frames you want to use in different keys. And transition is stuff like fade transition, fill transition, path transition, which are different changes of states of something, and we animate this change of state. And I think I've said what's on this. No? Since every class is almost at least is inheriting from animation, it has a number of predefined fields and methods like auto reverse and cycle count and rate and status, which we can read and sometimes also set. For example, auto reverse, if you want the animation to go backwards once it's finished. Cycle count, how many times we want this animation to run. Rate, the speed and direction. Status, if it's started, stopped and paused, because this is something that we see in almost all the different animations, namely that we define the animation, how it is supposed to work, and then we call start and it will begin to play. The easiest way of creating animations is through the transition subclasses. So we will begin with that. And as I said, the idea here is to change the state over time. Could be a fade rotation, so we see more and more until we see the entire image or text or whatever it might be. Rotate, which rotates. Path, which goes round a path, and so on. Anything that's a node, and that's most stuff, it's possible. And when I say that, images, yes, but the image view is what we are actually doing. And it's more fun to look at different examples. So first off, fade transition. We fade from one value going from 0.0, which is invisible, to 1.0 fully visible, or the other way around. We can set auto reverse, so it will fade up. So we'll see, in this case it will be an image, and it will fade back again. we can define the increments of this animation and how many times it should occur. And then when we are done with setting up this, we just call the play method and the animation will start. And it's then later on possible for us to pause it and then play it again if we like. In this example, we read a image, and you see we have fade transition, and we call it fade to black. It's a new fade transition, which will have a duration of 4,000 milliseconds, or 4 seconds. And it will work on Kylo Ren, which is an image view. More things that we set up is that we have from value 0.0, so invisible, to value 1.0. We don't have to have these. Well, I mean, we could stop at 0.5 if we like. And we have set by value 0.3, so it will be 0.3 more every time it updates the animation. Cycle count indefinite. It will fade out and in, out and in, out and in indefinitely, and it will auto reverse. And then just play. Nice. And if I had this running, it will look something like this. Really cool.
I will begin.
Again.
I will finish what you've started.
His mask is really, really ugly, but and fairly useless, yeah. It's uncool and useless. I don't really know. Maybe it will be revealed for us. Rotate transition works in all the transition animations works more or less the same. So in this case, we have something that we want to rotate. We do it an angle from initial state to 360 for a full circle. How many times? We use something called interpolation, which means basically that we define the movement at the start and the end of the transition. In this case, we will use something called ease. And ease means that it will rotate something, and when it's about to end, it will slow down the speed, so it looks like it's making a soft stop, and it goes back and it makes a soft stop. We take an image, we create a rotate transition. It has a duration, 3 seconds this time. We set an angle, 360, so it makes a complete circle. It will do this indefinitely and auto reverse, and as I said, it will interpolate ease both to make it look nice when it reaches the end. And I wish I had this one, but it's something like this. And I'm going around and around and around. All of these transitions are, of course, useful. You just need to find when you are supposed to use it. Another one, which is perhaps a bit more easy to understand why we are supposed to use it, is the path transition. And this transition works in like this. You basically set up a path, and whatever object you have, it could be a text, it will again be an image, but it could be a text, it could be, well, it could potentially be a combo box, but I don't know why. And it will move around this specific path. And we set a number of, we have a number of ways of defining this path with move to, line to. I borrowed this from the internet somewhere. No, a book, I think, actually. Cubic curve to, and so on. And it will go something like this, and then a soft angle at the end. We can also set the orientation. I say none, but actually I changed it later on. So it will for example, if you try out the example, you will see that it will rotate the object around the path as well, if you set it not to none but orthogonal. Yeah, you'll see it in writing soon. Here is the idea. We create a path transition, and in order for that to work, we create a path object of type path, and to this one we add a number of points, move to, line to, cubic curve to, which will give us these much smoother lines, and then we just add an image to this. We set a duration, we set the path to the transition, which is this one that we've decided, and the node, which is the image, and this and the orientation here, I say orientation type orthogonal to tangent, which means that it will actually rotate the object so that it follows the animation. And then we add everything up in our layout, and I wish I had this one, because it's again a TIE fighter, and it will move around slowly in front of the Death Star. And it's quite nice. It's hardware accelerated. It's nice for something that needs to animate in the background, or something that you want to animate many different times, or stuff like that. So it's really good. But for exact timing, you need to subclass one of the abstract classes, either animation itself, or more commonly the class called animation timer. And animation timer is really a general timer. The problem is that Java already has two classes called timer in util and in swing, so they decided for the name animation timer instead. But we most often use it in order to animate stuff anyway. And the idea is that the systems should send a pulse 60 times per second, so 60 frames per second, to a specific method. This method should do something, for example, change the position of a image or whatever it might be. And with this framework and hardware acceleration, we most often will actually get 60 frames per second in doing this. Important, of course, that you shouldn't have a calculation that is too complicated, because then that will be a bottleneck. But as long as it is fairly simple, you will be able to make these calculations so fast that the updates are possible 60 frames per second. I made a example, and I wouldn't say it's cheating, but it's a simpler way of doing it. I will, in this example, create an anonymous inner class, which just makes some stuff, will make some animation. For a more robust program, you should really create your own animation timer by inheriting from the animation timer, and set everything up in its own class instead. The animation timer needs to implement the method called handle, and this method is the one that's called 60 times per second. And in order for it to start, we again call start method. The code on the left side, you see code for just setting up the scene. In this case, it merely puts a TIE fighter onto the screen, but on the right side, and all of this is just one straight source code, so to say, so I just put them side by side. That one is the anonymous inner class, sorry, which defines a direction, if it's true or not, right is true or not. And then in handle, we check if we're going to the right or if we're going to the left. If we're going to the right and we haven't reached the end of the screen, we will continue on that side, and otherwise we will go to the left. And the important thing here is that we have the tie view set translation x, translate x to this new value, updated value. And it will try to do this as often as 60 times per second. And when we call start, the animation will start. And again, you won't see this, but it's a TIE fighter going from left to right, or rather right to left, right to left, right to left, indefinitely. And I've been able to set up exactly how fast and how often it should actually update. So that's quite nice, and it really gives you the fine-grained control over how your animation is supposed to work. Lastly, is there more to this? Yes. We haven't touched menus. COEs and other finance people really like applications with menus on top and toolbars and stuff like that. All of that is possible in JavaFX. There's also scroll bar, progress bars, the really nice tree views where you can create nice trees of whatever you like. JavaFX today covers almost everything you need and a bit more, and it makes it possible for you to create almost any program that you like. I do advise you to look at fxexperience.com and also the community page for JavaFX from time to time, because things are happening and there's loads of stuff happening all the time. With that, thank you very much, and may the force be with you. Thanks.